Hi there, folks. Today we're talking about deductive reasoning. All right. Deductive reasoning is kind of a foundational piece of geometry. This is going to set us up for doing things called proofs, where we do these two-column proofs. And really, it's just to helping us to structure arguments. All right. What we learn here we'll use from a mathematical perspective. All right. And we'll use it to say, hey, if we know this stuff, what can we prove to be true? And we follow this kind of logical progression. But that translates into making arguments about other things. Okay, one of the things that you can look up is that a lot of people who are very successful in things like law school were previously math majors. All right, people who were really good at logic and reasoning and that kind of stuff because the argument structures are the same. Whether you're talking about trying to prove something in math or trying to prove something in a courtroom. Okay. So, deductive reasoning is the process of reasoning logically from given statements to conclusions. So, all of this is based on kind of if-then statements, all right? And it's really important to understand, remember, if-then statements when we're deciding the truth value of those, all right? There's only one way for an if-then statement to be false, all right? And that's if we have a true statement followed by a false statement. If true, then false is the only scenario where it's false, okay? And we know that we have a truth value of true if we have a if true then true, all right? And that's kind of where this first thing, the law of detachment, comes into play. For example, if I look at something like this, if the hypothesis of a true conditional statement is true, so an if-then statement that we know to be true, and then we know that the hypothesis is true, I can now conclude that the conclusion must be true. All right, because there's only one scenario where an if-then statement is false, and that's if I start with a true statement and it ends with a false statement. All right, so if the conditional statement is true and the first piece is true, the last piece has to be true. All right, so here's the scenario. If P then Q, if we know that's a true statement and we know that P is true, well, it stands to reason then that we know Q also has to be true. All right, that's what this is saying. And yeah, when we look at it from this perspective of looking at it in terms of the if P's then Q's, that can be a little bit confusing, but let's use kind of a word type of example. All right, see if this clears it up a little bit. Something like this. If a student gets an A on the final exam, then they're going to pass the course. All right, so if I as a math teacher gave you that statement and said, hey, if you get an A, you pass the course. All right, that's what you need. So let's say that Lavender, all right, she got an A on the final exam. What can we now conclude about Lavender's grade? All right? And so here's the thing. If that original statement, the conditional statement is true, if she gets an A, she's going to pass. Well, she got an A. Now what do we know must be true? We know that Lavender's going to pass the course. And see, this is that thing in action, all right? We know that the conditional statement is true, right? So we know that this statement up here is true, and now it tells me right here, the first piece of this is right here. It's true, which means the second piece of it also has to be true. All right, so we can conclude that Lavender is going to pass the course. Okay, that's all this is saying. If I have an if-then statement that's true, and I find out that the hypothesis, the first part's true, I can now make the conclusion that the second part, that the conclusion is true. Okay. Let's talk about the law of syllogism. All right, and that's not only fun to say, and it sounds silly, but really we kind of already know how this works. All right, because it's basically like the transitive property. If you remember the transitive property was this one. It was if A equals B and B equals C, then guess what? A has to equal C. All right, I can kind of jump the gap. All right, this is the same thing but for conditional statements. All right, allows a conclusion to be made from two conditional statements when the conclusion of one conditional is the hypothesis of the other. All right, it's kind of this chain reaction, just like in the transitive property was A equals B, then B equals C. A equals C. Notice that middle piece, the end of one and the start of the next are the same. And so it's the same thing here. If I have if P then Q, and then if Q then R, well, what I can say then, the final statement I can make is if P then R would also be true. See, if I have a conditional statement that says, hey, if P then Q is true, and if Q then R is true, then the statement of if P then R, I can jump the gap and say if P then R is true. All right. And again, it's the same thing as the transitive property. If I know that A equals B is true and I know that B equals C is true, then I know that A equals C is true. Okay. It's the same thing, but with conditional statements. All right. And this is our foundation for arguments. See, we start to build things like if then statements that we know to be true, and then we connect those to make broader conclusions. All right. For example, if I look at something like this, it says if a figure is a square, then the figure is a rectangle. And these are true statements, okay? So let's assume that these are true statements. I'm giving you true conditional statements. So if a figure is a square, then the figure is a rectangle. If the figure is a rectangle, then the figure has 4 sides. So you see the conclusion that we can make, the new conditional statement that can be made that kind of jumps the gap? We could start with the first thing and say, well, if a figure is a square, then it has 4 sides. And again, we're just making a connection from one thing to the next. If a figure is a square, then it's a rectangle. If it's a rectangle, then it has 4 sides. So that means now that we can conclude that if a figure is a square, then it has 4 sides. I can make that leap. That's the law of syllogism. Okay? Again, very much like the transitive property. If I look at this thing, if a whole number ends in 0, then it's divisible by 10. We know that. Okay, this is an algebraic example. If a whole number is divisible by 10, then it's also divisible by 5. And we know that. Everything that is divisible by 10 is also divisible by 5. Okay? But now the conclusion that can be made, the conditional statement that we can make, is if a whole number starts with 0 or ends with 0, then it's divisible by 5. I can jump the gap. So instead of having to say, oh, it's divisible by 10, and then if it's divisible by 10, it's divisible by 5, I can jump to this if-then statement of if it ends in 0, then it's divisible by 5. Oh, just ran out of space. Okay? But again, it's important that these things are connected by that statement in the middle, all right? That the first if-then statement ends with the same state as the next if-then statement begins with. See here, in the first one, it was if square, then rectangle, and the next one started with if rectangle. That's important. Here it was if ends in a 0, then divisible by 10, and the next statement starts with if divisible by 10, okay? If I look at this one, it says, if you do yoga, then you are flexible. If you do gymnastics, then you are flexible. And students will kind of go through this and go, okay, well, let me just connect the first thing and the last thing. If you do yoga, then you are flexible. But the rule doesn't apply here because look at the end statement here. This one ends with, then you are flexible. And this one starts with, if you do gymnastics. Those pieces have to match in order to connect them in the middle. In order to bridge that gap, we need that connection. And when we don't have it, it means we can't do this one. So once again, this is, we'll just say NA for not applicable. Okay? We can't use the law of syllogism here because those middle pieces don't connect. Okay? And so this is how logic statements are started, like we start to do deductive reasoning, all right, is building these if-then statements and connecting those if-then statements so we can get from a starting point to an ending point, get from a given statement to a conclusion, all right? This is how proofs are formed, all right? This is how arguments are won, okay? If I look at something like this, it says, if you live in Pittsburgh, then you live in Pennsylvania. If you live in Pennsylvania, then you live in the U.S. And then we have another statement of, hey, Bob lives in Pittsburgh. Our buddy Bob, he lives in Pittsburgh. So what conclusion can be made? And so here we want to get to the furthest conclusion that can be made. The furthest conclusion that can be made is that Bob lives in the United States. Okay? And see, we can do that because, right here, when we look at these first two statements, we can use the law of syllogism and say, hey, Well, let me jump to a different color here so we can read it better. If you live in Pittsburgh, then you live in the U.S. Okay, so that's the conditional statement that I can make using the law of syllogism, using that thing that's like the transitive property. If you're in Pittsburgh, then you're in Pennsylvania. If you're in Pennsylvania, then you're in U.S. So I can make the conclusion that if you're in Pittsburgh, then you're in the United States. Okay, if you live in Pittsburgh, you live in the United States. But now it gives us another statement of Bob lives in Pittsburgh. And see, this is our law of detachment. See, we have a true statement to start with if you live in Pittsburgh. And then the second statement, all right, has to be true, which means that Bob, our buddy Bob, lives in the U.S. And that's the final conclusion that can be made. And notice we used both of those things to kind of come up with this. We used the law of detachment and the law of syllogism, okay? We can make that connection of Pittsburgh to the United States. And then now that we know that Bob lives in Pittsburgh, that's a true statement. So if Bob lives in Pittsburgh, then he lives in the U.S. If we have that first piece to be true, we automatically have the second piece to be true. All right. But it's about making those connections and following a logical progression of statements so that I can get from a starting point to an ending point. Okay. This is how proofs are done. This is how arguments are won. Okay.